All right, let's open the case file on what is, without a doubt, the biggest mystery in all of science. We're diving into a cosmic detective story where the crime scene is the entire universe, and 95% of it is missing. What you're about to hear might just change how you see reality.
Okay, so take a look at this. This chart shows you the sheer scale of our cosmic crime scene. See that tiny little sliver? That 5%? That's everything we've ever seen or touched. Stars, planets, you, me, all of it. The other 95%, this massive chunk of dark matter and dark energy, is a complete and utter mystery.
And this quote right here, it just drives home how high the stakes are. Without these two invisible components, galaxies would literally fly apart, and the expansion of the universe just wouldn't make sense. Our entire understanding of physics would basically collapse.
So, to solve this thing, we've got to go back to the very first clues. It all started when astronomers noticed the universe wasn't playing by the rules. This led them to what they called the case of missing gravity.
Now, our first two cosmic detectives on the beat were Fritz Zwicky and Vera Rubin. Zwicky, he stumbled upon the first clue way back in 1933, but then the trail went cold for almost 40 years, until Vera Rubin uncovered the definitive evidence that would blow the case wide open.
So, Zwicky was looking at this huge cluster of galaxies and saw something that was, it was impossible. These galaxies were moving so fast that they should have just flung themselves apart, like kids flying off a merry-go-round that's spinning way too fast. He realized there had to be some invisible mass, some extra gravity, holding the whole thing together.
So what was holding them together? It was like watching a race car take a hairpin turn at 300 miles per hour. You know an unseen force has to be gripping it to the track. But unbelievably, the scientific community just kind of shrugged and ignored this clue for nearly 40 years.
Then came Vera Rubin. She decided to measure how galaxies spin. Now, think about our solar system, right? Mercury zips around the sun super fast, while faraway Neptune just crawls along. That's how it's supposed to work. But what Rubin found was that stars on the very outer edge of galaxies were moving just as fast as stars near the center. It made absolutely no sense, unless the entire galaxy was sitting inside a massive, invisible halo of some kind of matter.
And boom, there it was, our first invisible suspect. They called it dark matter. Think of it like cosmic cement. It makes up 27% of the universe and provides that extra gravity needed to hold galaxies together. So case closed? Not even close.
Just as astronomers thought they were finally closing in on their culprit, the case took a shocking, unbelievable twist. Turns out, the universe wasn't just hiding something that pulls things together, it was also hiding something that pushes everything apart.
Okay, so in 1998, two different teams studying distant exploding stars made a discovery that would win them a Nobel Prize. For billions of years after the Big Bang, the universe's expansion was slowing down, right? Just like you'd expect gravity to do. But then, about 5 billion years ago, something slammed on the cosmic gas pedal, and the expansion started accelerating.
And this led to the identification of our second suspect, dark energy. This stuff is even weirder. It's some kind of anti-gravity that seems to be woven into the very fabric of space itself, and it makes up a mind-boggling 68% of the entire universe. So what we have is this incredible cosmic tug-of-war. You've got dark matter clumping together, pulling things into galaxies and cosmic structures. And then you have dark energy, spread out, all smooth and even, pushing everything apart. Our entire universe is basically defined by this constant battle between two invisible giants.
But this whole investigation has a major problem. Our two most reliable ways of gathering evidence are giving us completely conflicting reports on just how fast this whole cosmic getaway is actually happening.
This whole mess is called the Hubble tension, and let me tell you, it's one of the biggest crises in physics today. It's a huge clue that suggests there might be a fundamental flaw in our standard model of the universe, that maybe a key part of our detective manual is just flat out wrong. So let's look at the evidence log. On one hand, when we look at the afterglow of the Big Bang, the early universe, and use our best theories to predict how fast things should be expanding today, we get a speed of about 67. But on the other hand, when we measure the expansion directly using stars and supernovas nearby, we get a speed of 73. Now, that might not sound like a huge difference, but in cosmology, this is a 5-alarm fire. The numbers don't lie, and they're screaming that something is deeply wrong with our story.
This tension has forced our cosmic detectives to consider two very different lines of inquiry, which means two very different profiles for our mysterious cosmic suspects.
So the debate really boils down to this. Are we just missing some invisible stuff in the universe? Like exotic particles we just can't detect yet? Or are the very rules of the game, the laws of gravity that we've trusted for centuries, actually broken when you get to cosmic scales?
One of the main suspects in the broken rules camp is a theory called MOND. It basically says that gravity itself just works differently on a galactic scale, and it's really brilliant at one thing. It explains why galaxies spin so fast without needing any dark matter at all. But it has a pretty weak alibi. It just can't account for the evidence we see in giant galaxy clusters or when we look back at the early universe.
Now here's the kicker. Finding these culprits isn't just some academic puzzle. The answer to this 95% problem will literally determine the ultimate fate of our universe, the end of everything.
The true nature of dark energy is going to write the final chapter of the universe. If it's just this constant, steady force, we're headed for a big freeze, a cold, dark, empty future. If it weakens over time, gravity might just win out, pulling everything back together in a big crunch. And if it gets stronger, well, that could lead to a big rip, where the fabric of reality itself is literally torn apart.
Michael Turner, the very astrophysicist who came up with the name dark energy, he put it best: our entire cosmic destiny is completely tangled up in solving this one mystery.
But listen, this is no cold case, not by a long shot. A new generation of powerful detectives, amazing observatories like the Euclid and Roman space telescopes are on the beat right now. They are creating the most detailed maps of the dark universe ever made, designed specifically to gather new clues.
We are really standing on the brink of a revolution. For centuries, our best theories have described the universe with stunning precision, but we now know they only apply to that tiny 5% of reality we can actually see. The other 95% is still out there, just waiting for a breakthrough.
The evidence is clear. The solution has to be a new physics, something beyond anything we currently understand. As our new cosmic detectives deliver their findings, they might just finally unmask the culprits. And in solving the case of the missing 95%, they might just reveal a universe far stranger and far more wonderful than we ever dared to imagine. The case remains open.